All right, let's check out page 394. Yesterday we were solving trig equations where we're trying to figure out a particular angle that would give us either a sine value, a tangent value, cosine value, whatever the case may be. And we're just going to wrap it up today. We have a few more examples to go over. It's not going to take all period. Okay, so you'll have plenty of time to get started on some homework or get some of that done. Tomorrow we're going to have a free response day, which means Monday we will be having a partner quiz. Okay, so I'll let you know who you're working with tomorrow. The partner quiz is non-calculator, okay, which means we should be able to use the unit circle in some capacity. Okay, we did a few of those yesterday. I still haven't really determined whether I want to give you a unit circle tomorrow or not, or on Monday or not, because we do have to know it. But I'm telling you right now, you will not be getting one for the test. Okay, so whether I give you one on Monday or not, still haven't decided. I'll let you know tomorrow though. Okay, so we can prepare for that. But regardless, it's non-calculator. Okay, where did we leave off yesterday? I know we're on page 394. I just forget which question we were on. Did we finish this one? We finished the second. Okay, so now we're on the third, the cosecant one. All right, so yesterday we need to think about where this angle might be located, like in which quadrant, and we'll go ahead and utilize the calculator to give us one of the angle measurements, but remember it's up to us to figure out the other one. Your calculator can only do so much, your brain can do more. Okay, so let's just maybe think about first, notice how this equation is cosecant. And if we're going to use a calculator to help us out, we only have sine, cosine, or tangent buttons. How can we turn cosecant into one of those three other trig functions? Yeah?
1 over cosine.
One over what?
Would you use cosine on the bottom?
It's actually sine. And this is a common misconception. Like, people think that since this one begins with a C, it would be the cosine reciprocal. It's actually not. Okay, common misconception though. All right, so we can change cosecant into 1 over sine. We're trying to figure out what theta is. Notice how theta is in the bottom of a fraction. We don't really want it there. So if we flip the left-hand side, we must flip the right-hand side. So we would need 1 over that decimal. Okay, can we type that in on our calculator? 1 divided by negative 1.235. So we'll write down negative 81. Maybe you want to round it. All right, so let's take a look at this a little bit further. Now that it's in sine, that might be a little bit easier for us to work with. Notice how the sine value we want is negative. So can we think about which quadrants this angle theta should be located in? Think about which variable sine's related to on the unit circle. Where would we be? Yeah?
You said it would be quadrant 3 or quadrant 4.
Why? That's good.
Well, because sine relates to y.
Mm-hmm.
In this case, y is negative.
Y is negative. Good. So sine is representing a y value. Y values are negative in quadrants 3 and 4. Perfect. All right, so we know where the two angles are located. Let's see if we can figure out what those exact angles are. So on your calculator, we're going to have to go ahead and move the sine value over. That would bring in a sine inverse. Some mathematicians refer to that as arc sine. Not sure if you've seen that before or not. In some textbooks you might see like arc sine, arc cosine, arc tangent. That just means inverse. We get into that a little bit more in calculus. But it's just a synonym. All right, so if you were to type this in on your calculator, be careful. Okay, if you look at the directions at the top, Notice how we want theta to be between 0 and 360 degrees. All right, so you got to make sure your calculator's in degree mode. If you were to type that in, what would your calculator give you? Yep.
Negative 54.1.
Negative 54.1. Okay, I'll take it. So, if that is our angle measurement, if you were to draw a negative 54.1 degree angle, which angle would you have? The one in quadrant 4 or the one in quadrant 3? Yeah. Quadrant 4, right. So this measurement, if you were to go backwards 54.1 degrees, you would land in quadrant 1. Or sorry, quadrant 4. My mistake. Now, what we got to be careful with is if we're landing in quadrant 4, the angle measurement should be something between 270 and 360. So if you notice what your calculator is giving you, okay, it's not necessarily giving you the exact angle measurement, it's giving you a way to determine the exact angle measurement. You see the difference? Okay, so can we think about which angle in quadrant 4 this one would represent if we can travel 54.1 degrees backwards? Something between 270 and 360. Good, Maddie? Okay, so your calculator is giving you an angle measurement of negative 54.1. If you were to draw that negative angle, you would have to travel backwards from this starting point. If you travel backwards 54.1 degrees, you would land here. But if you're landing in the 4th quadrant, you should have some angle between 270 and 360. We're trying to figure out, even though the calculator gave us negative 54.1, we got to figure out what the exact angle measurement is. What do you think, Marie? 305.9. How'd you get it? There you go. All right, so the 360 is if you were to do a full circle, we want to go backwards 54.1 degrees, so that would give us 305.9. Notice how that number is in between 270 and 360. All right, so that is technically the answer the calculator gave us because we got that angle measurement from the 54.1. We have to figure out what this other angle is over here, okay, in quadrant 2. So that angle should be something between 180 degrees and 270. Now we're going to go ahead and use the 54.1 degree measurement in this 3rd quadrant. That would be the same reference angle. Okay, they're symmetric, just like the unit circle has those symmetry or folding properties. So can we figure out what the second angle might be? What do you think, Maddie?
234.1.
I like it. 234.1. So take 180 and add 54.1. Notice how that angle measurement's between 180 and 270. Okay, so we're good to go. Since we have a calculator, I would suggest checking your work. So what you can do on your calculator, maybe we'll use the sine equation that we rewrote the original one as, because we have a sine button. If you were to type in sine of 305.9, we should get negative 0.81, which we do. Okay, we're not necessarily checking the original number, we're checking the one that we rewrote. So negative 0.81. Let's go ahead and check the other one that we found. We type in sine of 234.1, and we get the same thing. Okay, so you can check your work when you have a calculator. We didn't lose it from yesterday, did we? If we did a little bit, I hope it comes back. Okay, let's go ahead and try the next one. We want to make sure it's either sine, cosine, or tangent, because those are the buttons we have on a calculator. Notice how tangent is already given to us, so there's no changing needed like we did in the previous one. let's see if we can think about which quadrants we might be in. So our tangent value is negative. Think about how tangent is related to x or y on the unit circle. And if that is negative, where would we be located? What do you think, Manny? It's the other way around, y over x. Okay? So if that fraction is negative, think about how a fraction could be negative. Where might we be located? Yeah.
You could be in either quadrant 2 or quadrant 4.
Because?
Well, both the y and x could be negative, so the x is negative, it will land in quadrant 2, the y is negative, it will land in quadrant 4.
Right. So they both can be negative, just not at the same time. Because then that would make the fraction positive. Okay, so either y is positive and x is negative, that would put you in quadrant 2, or y is negative and x is positive, that would put you in quadrant 4. Okay, but they can't be both negative or both positive at the same time. Looks good. All right, so let's let the calculator give us one of those angles, and we'll go ahead and try to figure out the other one. So on our calculator, we'll move the tangent over, be tangent inverse, or arctangent. What angle measure does the calculator give you? Good?
Negative 41.7 degrees.
0.7 degrees. All right, if you were to draw that negative angle, which quadrant would you land in? If you were to go backwards, 41.7. Would we have the quadrant 4 angle or the quadrant 2 angle? Yeah. Quadrant 4. So if we were to travel backwards 41.7 degrees, we would land right here. That, however, is not the theta answer we need, because if we're in quadrant 4, we need something between 270 and 360. So the calculator is giving you an angle measurement to help you figure out the correct one. It's not necessarily the final theta measure, like it was in previous examples. Go ahead, Maddie.
318.3.
You got it. We'll go backwards from 360. All right, now we got to figure out the one in quadrant 2. If this reference angle was 41.7, then the reference angle in quadrant 2 is also 41.7. We have all this symmetry and connections going on. So if we're in quadrant 2, we need something between 90 and 180. Good, Maddie? It would. All right, let's check those out. On our calculator, we'll check our work. We'll type in tangent of 318.3. We get negative 0.891. Okay, that's really close to the exact number we started with. We're off just a little bit because we rounded that 41.7, but I'd say we're really close. If we type in the one that we had to find, 138.3, notice how we get the same thing. Okay, so we found both angle measurements that would satisfy this trig function, or trig equation. Good job, guys. All right, we're going to try some more. Let's go ahead and check out the two that are left on the next page. So these are going to be very similar. Notice how they're the same setup. Okay, cosine of theta equals something, cotangent of theta equals something. This time, though, if we pay close attention to the directions, we want to find two values for theta between 0 and 2 pi. So we're no longer working in degrees. We're going to go ahead and work in radians. So this is when we got to be careful. If we're going to use the calculator, we have to change that program or change that mode. So on your calculator, go ahead and switch from degrees to radians. You have to be careful as to which unit of measure you're working with. Okay, but the process is still the same. Okay, it doesn't matter if we're working in degrees or radians, we're still trying to figure out which quadrant we're in and then the angles that those quadrants, or the angles in those quadrants would have. So let's check this one out. Cosine value is negative. Can we think about which quadrants we'd be in? Go ahead, Maddie. 2 or 3, perfect. Cosine's an x value, so we're in 2 and 3. All right, let's go ahead and utilize our calculator to move the cosine over. What'd the calculator give you? Yeah? 2.967. Okay, so this is representing a radian amount. It's not a degree anymore. Okay, we have radians. So, just like we did in the previous examples, and we labeled like 0, 90, 180, 270, 360, we labeled what all the axes were. Maybe we'll do that with radians. All right, we always start on the right-hand side, so that's 0. Do we know what 90 degrees is as a radian? Do we know what 180 degrees is as a radian? Good, Rebecca? Pi, right? That was our conversion factor. We would multiply by 180 over pi or pi over 180. Those two are related to each other. So if pi is 180 degrees, that means 90 would be half of pi, or half that distance. The bottom would be 3 pi over 2, aka 1.5. And if we did a full circle, that would be 2 pi. Okay, now what's a little tricky is this 2.967 already has the pi multiplied in. For instance, on your calculator, if you were to type in pi divided by 2, which is our 90-degree point at the very top, that would be the same as 1.57. So this is what I want you to remember it as, okay, pi over 2, but as a decimal, that's 1.57. We know pi is 3.14. If you were to type in 3 pi over 2, that'd be 4.71. And 2 pi as a decimal is 6.28. So notice how our calculator is giving us an angle measurement of 2.967. Which angle does that represent between the two that we drew? Is that the quadrant 2 or the quadrant 3? If we really pay close attention to those decimals. What do you think, Rebecca? Go ahead.
The quadrant 2 one,
How'd you know?
because 2.9 is between 1.5 and 3.4.
There we go. So very similar to how we could compare degree measurements, like we should be between two numbers. It's the same concept for radians. It's just a little trickier because now we have decimals to compare, not just necessarily whole numbers. So this angle measurement, if you were to start on the right-hand side and travel all the way over, would be 2.967. So there's one theta value. What we got to do, okay, that's the one the calculator gave us. What we need to do is figure out the one in quadrant 3. So we should have something between 3.14 and 4.71. How might you want to find that angle? You could kind of approach this two different ways. What do you think, Tori?
I actually have a question for
Yeah.
you. Why is this one different where it's like going from right from the start to 2.967 not just being a reference number? Like why isn't the one coming from the high side?
Like, why isn't it coming from this one?
Yes.
Okay, so what your calculator is giving you is sometimes it'll give you the reference angle, which is just a little amount. Sometimes it'll give you the full angle. If you take a look, what's the one that we had from yesterday? All right, if you look at the one from yesterday, this cosine one, in degrees, it gave us 118. So that would be if we started here and went all the way around. This one from yesterday, it gave us 47, which would be that amount. So sometimes it'll give you the reference, sometimes it'll give you the exact one. It just depends on the trig function and the value. But it's how you analyze it to make sense of it. Is that okay? All right. So how might we be able to figure out this second angle in quadrant 3? We could approach it two different ways. We can figure out the reference angle, like Tori was mentioning, or we could do something else. What do you want to try, Rebecca? Go ahead.
Simply subtract 2.967
Mhm.
from 6.3.
Okay, so instead of traveling 2.967 positively to land in quadrant 2, we could travel 2.967 negatively, and that would make us land in quadrant 3. So you could do that. Another thing you could do is possibly figure out the reference angle, okay, this little measurement, and if that's the reference angle in quadrant 2, we should have the same reference angle in quadrant 3. Okay, you could approach it from that aspect using a reference angle. Either way, we should get relatively the same value. Maybe we'll try Rebecca's. So we got to take 6.28, which was 2 pi, and we will subtract 2.967. I think we should get 3.313. Does that sound about right? Okay, we have a calculator, so we can check our work. Let's go ahead and type in cosine of 2.967. We get negative 0.9848. All right. That one is the one the calculator gave us, though, so it kind of makes sense that that one should work out well. Let's definitely check the one that we had to figure out. So cosine of 3.313. I'd say we're pretty close. Okay, we're off slightly because of the rounding, but it's still around the correct measurement, I'd say. All right, so I don't want us to get too worked up because we're working in degrees. It's the same process, it's just now you're working with a little bit trickier values because they're decimals instead of degree measurements, yeah.
Could you solve it entirely in degrees and then just change your answer to what you want?
Or you could do that, yep. So if you're more comfortable in degrees, you can convert it, yep. All right, let's try the next one. We're going to try to keep it in radians, though, because I want us to get comfortable, all right? Cotangent, we need to somehow rewrite it in sine, cosine, or tangent, because those are the buttons we have on the calculator. So how is cotangent related to one of those? Cotangent is the reciprocal of... Good, Marie? Tangent. All right, so 1 over tangent. We have a theta in the denominator that we're trying to solve for. We want it in the numerator, so we'll flip the left-hand side, which means we have to flip the right-hand side. So 1 divided by 5.671. We'll get 0.1763. All right, so this is kind of our new equation. If you want to ignore the original one, that's completely okay. So we can just work with this one now. We have a tangent value that's positive. Which quadrants are the angles located in? Yeah? 0 and 90. Okay, so definitely in quadrant 1. Remember, tangent is y over x, so we need a positive fraction. Yeah? It could also be in 3, where both x and y are negative. Okay? All right, so let's go ahead and let the calculator find one angle for us. We'll move the tangent over using the inverse. We have 0.1745. Okay, now we have the decimals labeled on the one on the left, if you want to reference those, or maybe you want to write them on this one. We have pi over 2, which was 1.57, pi 3.14, 3 pi over 2, 4.71, and 2 pi 6.28. If you were to draw an angle of 0.1745 radians, which quadrant would you land in? Is it the one in quadrant 1 or quadrant 3? Go, Rebecca. Quadrant 1, right. That decimal is between 0 and 1.57. So in this case, notice how it's giving us that reference angle, 0.1745. So there's one angle measurement. If that's the reference angle in quadrant 1, the reference angle in quadrant 3 is exactly the same. So it looks like we'd have to take pi and add that reference angle measurement. What's our other angle? Three-point something. Bless you. Let's see, 3.3145. All right, let's check our work. We'll plug it in, see how we did. We'll go ahead, bless you. We'll use the tangent equation that we rewrote. So we'll type in tangent. I think we can trust the 0.1745 value. That's the one the calculator gave us. Let's go ahead and test the one that we had to find. So we'll plug in 3.3145. And notice how we get 0.1763, something really close to it, but again, we're slightly off because of some rounding. We rounded this decimal, we rounded pi. Okay, if we were a little bit more accurate, we'd be a little bit closer. But notice how it's still really close. All right, are we doing okay? Using a calculator, figuring out where the angles are. You have to do a little figuring. Okay, a calculator gives you one, you got to figure out the other. But I think we're doing okay. All right. We'll have our free response day tomorrow with more practice, and then our partner quiz on Monday. All right.